This is video number 354, and in this video I'm going to use stationary time series for estimation of alternatives, various alternatives, and selection of the best model. So here I'm discussing some of the theoretical underpinnings, and in the next video I'll use some simulated data to estimate and select the best model. So in this case of stationary time series, we will be looking for estimation and the best model selection. So we'll decide on plausible alternative specifications, including ARMA, and then we'll estimate each specification, that is AR1, AR2, MA1, MA2, and so on, and then we'll choose the best model, which will be based on the significance of the coefficients and the fit versus parsimony criteria, and also we will look for whether the residuals are white noise or not. So the best model means that the various coefficients of the variables must be significant, and the model may be best fit. So there may be a trade-off between the fit versus the parsimony. If we include additional variables, we may improve the fit, that is the R square and the adjusted R square may increase, but we lose the quality of the forecasting. It may reduce the quality of the forecasting. And if we want to have parsimony, then we may be using fewer variables as compared to many variables, and in that case we may not have the best fit. So we'll be doing that. Finally, we'll be discussing whether the residuals are white noise or not, and whether they have the ability to forecast or not, and then we may also account for possible structural breaks, but that we will do in the later videos. Now, regarding the question of fit versus parsimony, we may use various information criteria. So if we use additional parameters, that is more legs, that will automatically improve the fit, that is that will increase the value of the R square, that is the coefficient of determination, but it may reduce the quality of forecast. So it means there may be trade-off between the fit and the parsimony, and for that we may use various criteria, and the most widely used criteria are Akaike information criteria, which is known as AIC, and the objective is to have lower AIC. And similarly, we may also use Schwarz Bayesian criterion, that is SBC, and the objective is also to have lower SBC if we use this criteria. So far as Akaike information criteria is concerned, that gives more value to fit, to best fit of the model, and the Schwarz Bayesian criteria is more concerned about the parsimonious model. So SBC will tend to prefer more parsimonious model than AIC, and AIC gives more value to the better fit rather than the parsimony. And after that, we'll also be looking at whether the errors are white noise or not. So our aim is to eliminate autocorrelation in the residual. So we'll be plotting the standardized residual, and we may be interested in finding out that no more than 5% of the residual should lie outside plus minus 2 over all periods. And for that purpose, we may also look at the autocorrelation, coefficient of autocorrelations and coefficient of partial autocorrelation, and their significance at various legs. And finally, we may use the Box-Jenkins method, which is used for joint significance test up to leg S. So the null hypothesis is that all RK, that is all um, autocorrelation coefficients are equal to 0, where K is equal to 1, 2, 3 up to S. And the alternative hypothesis is that at least one of these autocorrelation function coefficient is not equal to 0. And this is the formula for the Q statistic. So if the calculated Q statistic is greater than the tabulated T value, then we reject the null hypothesis and we may conclude that at least one of the coefficients is not equal to 0. So, ladies and gentlemen, uh, I'll be using these theoretical underpinnings in the next video, in which I'll estimate alternative specifications of ARMA, and then we will select best model, and we'll consider the significance of the coefficient, and we may also consider fit versus parsimony, and we may also look at the white noise residuals that may have the ability to forecast and may account for possible structural breaks. And we may use either a Kaike information criteria or Schwarz Bayesian SBC criterion. But objective in both criterion is to have lower AIC and lower SBC. So, ladies and gentlemen, you should also watch the coming video, that is video number 355, in which I'm using simulated data of AR1, AR2 and MA1, and then I'll compare, and probably AR1 best fit the simulated data, and I discuss the significance of the coefficients, the lower AIC and SBC criterion, and so on. So we will also look at the white noise errors and plotting of standardized residuals, and we will be examining and inspecting the autocorrelation functions and partial autocorrelation functions and Box-Jenkins method. So thank you for your attention. If you haven't yet subscribed to this channel, kindly do subscribe, and do not forget to click on bell icon so that you can get notification about my other videos that I'll upload. Thanks again for watching my channel and video. Kindly do share this channel and videos with your friends, with your colleagues, so that they can also get benefit. Thank you and have a good night.